Hello, this is Prof. Nanius. This is a series of videos on algebra review. We're going to be doing quadratics, the algebraic part of quadratics today. So let's get started. And get up there, and well, it's not exactly what I wanted. There we go. Let's hide this. There. So quadratics, how to solve them, basically, algebraically. So how to solve. And other topics. So the idea here, what a quadratic is, it's a degree 2 polynomial, things like 3x squared plus 5x minus, let's say, 4. And solving them would mean setting equal to 0. Now there's basically two ways of doing this. And the two ways, which are actually related, there's something we'll call one, completing the square. Which will be useful, so we'll do that. And the second one would be the quadratic formula. Now, it turns out that the quadratic formula comes from completing the square, but I'll go ahead and use the quadratic formula first. A lot of people just want to know what the formula says. So what the quadratic formula says is that if you're given a polynomial, given a quadratic ax squared plus bx plus c, and you want this to be 0, and you assume that a is not 0. And if a were 0, then you'd have mx plus b, and we know what to do there. There would no longer be a quadratic. The solution is given by x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. And if b squared minus 4ac, this is called the discriminant. And if this is greater than or equal to 0, you have real solutions. If this is negative, then you have the square root of a negative number, which means there's an I in the answer, and the solution is complex. In our course, we're going to be worried about the real solution, the real number solution. So let's look at real number solutions. So let's look at our little example here. X squared plus 5x minus 4. Here, a is 3, b is 5, c is a negative 4. So plugging into our quadratic formula, we know our x is going to be minus 5 plus or minus b squared, that's 25, minus 4 times 3 times minus 4 over 2 times 3. So 4 times 4 is 16. 16 times 3 is 48. So you add these two, and you get what? 13, 73. So the answer to this x is either going to be x will be minus 5 over 6 plus the square root of 73 over 6, or x will be the negative. Minus 5 over 6 minus the square root of 73 over 6. And that, you might need a decimal answer for your engineering course or whatever, but in our course, these would be perfectly legitimate answers. Now, the second question is I mentioned completing the square. Well, how would you do this by completing the square? So the one thing to remember, So we're going to talk about completing the square, which is another method. And really, the quadratic formula really is that. But let's go ahead and take a look. What this means is like if you have something that looks like, let's say, x plus something squared, you square that out, so it's x squared plus 2 alpha x plus alpha squared. So this is a perfect square. And what we notice right here is if you take this number here, if you take 2 alpha, and if you divide that by 2, and then you square it, you're going to get this exactly. So let's use that same principle here. We have 3x squared plus 5x minus 4 equals 0. Let's divide by 3. And notice if you divide both sides by 3, that doesn't change. Now, let's take this x squared plus 5/3 x. Now let's take this, divide it by 2, and square it. But because we added this, we better subtract it as well so as not to change the answer or not to change the equation. So I added 5/3. I divided by 2, squared it, added it, but then I had to subtract the same thing, so I didn't change anything. So what does this mean? Well, what this means is this is now by design a perfect square. This is now x plus 5/6, because that's what 3 times 2 is, quantity squared. Now notice I can move this to the other side. This is 4/3 plus 5/6 squared. All right? Now, what's very interesting here is that this side, I'm going to get a common denominator. So this is 4/3 plus 25/36. So this whole thing getting a common denominator, I'm going to multiply the bottom by 12 and the top by 12. So that's going to be 36. So that is what we had before, 73/36. Now let's take the square root of both sides of here. If I take this square rooted, I get x plus 5/6. That's going to equal plus or minus the square root of 73/36, which means x is equal to minus 5/6 plus or minus the square root of 73/6. And notice 5, so we have that minus 5 plus square root of 73/6. So we get the same answer by completing the square. So what I'm going to do now is I'm going to tie together the quadratic formula and completing the square. So why are these equivalent? QIV. Well, again, suppose you have ax squared plus bx plus c is 0, and a is not 0, or else you wouldn't have a quadratic. Division by a, there's an x. Now, let's complete the square on this side. So this is x squared plus b over ax. Then you add b over 2a squared. And then you got to subtract that to make sure you don't change anything. So you add and subtract the same number, this b over 2a squared. This is now a perfect square. So this is now x plus b over 2a squared. Now I'm going to go ahead and subtract. I'm going to add this to this side and subtract that. So this is going to be b squared over 4a squared minus c over a. Now we're good. We're going to be good algebra students here. What I'm going to do is I'm going to multiply this, and I'll just do this here. I'm going to multiply this by 4a, and I'll multiply this by 4a. So on this side right here, I have b squared minus 4ac. And notice we have a common denominator, so that's 4a squared. Now you square root both sides. So that's going to be plus or minus the square root of b squared minus 4ac. And there's your discriminant. Square root of that is going to be 2a. So now x is equal to minus b over 2a plus or minus square root of b squared minus 4ac over 2a, which gets us to our usual quadratic formula. And that's what x is, those two numbers. So that's a nice quick and dirty about the quadratic formula. Now there is one final thing that it's worth mentioning. And this is a very special case I want to talk about. And this happens enough to where it's worthwhile. And suppose you have something that looks, well, I'll go ahead and explain it. If you have, let's say, a minus b times a plus b, and if you multiply this carefully, what you find is this is a squared minus b squared, because you get a squared minus ab plus ab, such and such. So conversely, if you have the difference of two squares, it factors like this. So it's like, suppose you have 3y squared minus 16x squared. Well, this is going to be factored as the square root of 3y plus the square root of 16, which is 4. And this will be the square root of 3y minus 4x. Because notice 4 squared is 16, x squared is x squared. So that's a very nice little factorization that will help you out. So that's a little brief review of quadratic formula and completing the square. So let's stop the share, and thanks for watching.